In 11th class physics, there is an important derivation of equation of motion by calculus method. Let us see how we derive it. So first equation of motion is V equal to U plus AT. All equation of motion is valid only if acceleration is constant. So in this equation, A represents constant acceleration and U represents initial velocity of the motion. Therefore, U will be constant throughout the motion. So in first equation, there are two variables V and T. Now to derive this equation, we have to use a relation between V and T in terms of constant. Then we can integrate it to find this equation. Can you tell me the relation between V and T in terms of constant? There is a relation. A equal to dV by dt. In this equation, A is constant and V and T are variable. So we have this relation. Now using this relation, we can find out the relation between V and T. And how can we find out? We first cross multiply dt into left side. So we have the relation A dt equal to dV. Now we integrate both sides with proper limit, and for this we introduce limit related to variable t and v. Suppose initially at t equal to 0 velocity is u, and suppose at any time t velocity is v. Now using these limits we integrate both sides this equation. Left side we put the limit of t, lower limit 0, upper limit t, integration of a dt. Right side we put the limit of velocity, initial velocity u and final velocity v, integration of dv. Now we integrate it using the rule of definite integration. Here a is a constant factor, so it can be taken out of the integration. And here there will be 1 dt. So integration of 1 with respect to t will be t. So we can write here integration of 1 as t, and we put the limit, lower limit 0, upper limit t. Here in right side also we have to integrate 1 with respect to v. So integration of 1 with respect to v will be v. And now we put the limit, lower limit u and upper limit v. Now we solve it according to rule of definite integration. So it will become a into inside the bracket upper limit t minus lower limit 0. Similarly, in right hand side, we put upper limit in place of v minus then lower limit in place of v. So it will become v minus u. Now we solve it. So on solving, we get v equal to u plus at, which is the first equation of the motion. Second equation of the motion is s equal to ut plus half at square, where s is the displacement during the motion, u is the initial velocity, so it is constant throughout the motion, a is the constant acceleration of the object during the motion. So this equation is the relation between two variables s and t. Now to obtain this equation, first we find out the relation between variable s and t in terms of constant. Can you tell me a relation? Now there is no direct relation between s and t in terms of constant. But we can obtain this condition by using the relation between s and t in terms of variable. We have a relation v equal to dx by dt. Here dx is the displacement and v is the velocity at time t. So here x, t and v all are variable. Therefore, at this point we cannot use integration to solve it. Variable v can easily be replaced because in first equation of motion we have relation v equal to u plus at. In this equation v is related to just one variable t, which is desired variable. So if we replace v with this equation, then we have required relation for the integration. So v is first replaced by this relation, and then we have the relation u plus at equal to dx by dt. dt is crossed multiply, so we have relation u plus at dt equal to dx. Now we have only two variable, so we can integrate both sides with proper limit. For this we introduce proper limit first. Let at initial time t equal to 0, the position of the object is x1, and let any later time t, the position of the object is x. Now using these limits, we integrate both sides of this relation. Left side the variable is t, so we put the limit of t here, lower limit 0 and upper limit t. Right side variable is x, so here in integration we put limit of x. Lower limit is x1 and upper limit is x2. Now we integrate using definite integration rule. Here we integrate these two terms separately, so it will become u dt limit of 0 to t. Second term will be at dt with limit 0 to t, and right hand side will be integration of 1 dx limit x1 to x2. Now using definite integration rule, we solve this integration. U being a constant factor can be taken out of the integration. So inside the integration, it will be 1 dt. Integration of 1 with respect to t will be t. So inside the bracket, we write t and put the limit 0 and t. Plus similarly a is a constant factor here, so it can be taken out of the integration. So integration will be t dt. The integration of t will be t square by 2, which we write inside the bracket and put the limit 0 and t on the bracket. Right hand side there is a integration 1 with respect to x, so its integration will be x, and we put the limit here also. Now here we put upper limit first, it will be t, minus then lower limit, it will be 0, plus a. Here also we put first upper limit, it will be t square by 2, minus lower limit, it will be 0. Equal to, here also we put upper limit first, minus then lower limit, so it will be x2 minus x1. Now we solve it. So on solving, it will give relation ut plus half at square equal to x2 minus x1. x2 minus x1 is the difference between final position and initial position. So this is the displacement of the object. Let me assume displacement x2 minus x1 equal to s, and replace x2 minus x1 with s. So this equation now will become ut plus half at square equal to s, which is the desired equation. So this way we can derive the second equation of the motion. Now we derive the third equation of motion, which is v square minus u square equal to 2as. Here the variable quantity is v and s. S is displacement and v is the velocity at any time t. U being the initial velocity is constant throughout the motion, and in equation of motion a is always constant. So a is constant acceleration. Now to obtain this relation, first we have to find out the relation between variable v and s in terms of constant, so that we can integrate it to find out the relation. We have a relation for acceleration a equal to dv by dt. Now on the right side we multiply dx and divide dx. In the denominator dx is written under the dv and dt is written under the dx. So dx by dt will become v, and we have a relation a equal to v dv by dx. Here is the variable is v and x, and a is the constant. So we have the desired relation between v and x in terms of constant a. Now we can solve this relation easily by integration method to obtain the desired equation. See how. First we cross multiply dx, so the equation will become a dx equal to v dv. Now we integrate both sides with proper limit. For this we introduce proper limit first. Let initial position of the object be x1, and at this position the initial velocity be u. Let the final position at later time t of the object be x2, and the velocity of the object at this point be v. Now we integrate this relation both sides with proper limit. Left side variable is x, so the limit of x is taken, lower limit x1 and upper limit x2. Right side variable is v, so in the integration limit of v is taken, lower limit u and upper limit v. Now we integrate it using the rule of definite integration. Now a being the constant factor can be taken out of the integration, and now we have integration of 1 with respect to x, which will be x, and we put the limit lower limit x1 and upper limit x2. On the right side integration of v will be v square by 2 with lower limit u and upper limit v. Now here in place of variable, first we put upper limit x2 minus then lower limit x1. So it will become x2 minus x1 into a. On the right hand side also in place of variable, we put upper limit first, it will be v square by 2 minus then we put lower limit, it will be u square by 2. So right side will become v square by 2 minus u square by 2. Now x2 minus x1 represents the displacement of the object. Suppose we replace it with s. then this equation will become A into S equal to V square minus U square by 2. Now we cross multiply 2, then we have the relation V square minus U square equal to 2AS, which is the desired equation. By this way, we can find out the third equation of motion by calculus method. So we have derived all equation of motion by calculus method. Hopefully you have got it right properly.